Dear students, welcome back to yet another session on e-learning. I am Dr. P. Geeta, Associate Professor, EC Department, Hindustan College of Engineering and Technology. Today, let us see about the minimization of Boolean functions using Quine McCluskey method. In this session, we'll be learning about the methods of minimization of Boolean functions and Quine McCluskey minimization in detail and the advantages and disadvantages of Quine McCluskey method. Let us see what are all the methods of minimization of Boolean functions. So there are three methods for minimizing the Boolean functions. They are algebraic reduction, Carnot map minimization, and Quine McCluskey minimization. So let us see about Quine McCluskey minimization in detail. Let us take an example and then see how this expression is being reduced using this method. So the given problem is simplify the logic function y of a comma b comma c comma d, which is equal to summation m of 0, 1, 3, 7, 8, 9, 11, 15. So the first step is we have to ensure that the given problem is in the format of sum of minterms. If it is not in that format, we have to convert it into sum of minterms by either using De Morgan's law or any other theorems and postulates. The next step will be we have to find out the binary equivalent of each and every minterm and then have to group them according to the number of zeros available in their binary value. So that is given in the table 1, which is shown in the next slide. So the table 1 shows the first column where you have different groups 0, 1, 2, 3 and 4, and the next column consists of the minterms given in the problem, and then the next column will be the binary values of the minterms, and the last column will be the column used for placing the tick mark. So the minterms are grouped according to the number of zeros. So the first group 0, it contains minterms with 4 zeros. So given in the problem only 0 comes under this category. So we take minterm 0 alone for group 0. Coming to the next group 1, this group consists of 3 zeros and minterms 1 and 8 come under this category. The next group consists of 2 zeros in the binary values and minterms 3 and 9 come under this category. Group 3, it has a single 0 and it covers minterm 7 and 11. And the next group and the last group, that is 15, it contains minterms with no zeros and only 15 comes under this category. Now let us go to the table 2. So when explaining about the table 2, I'll explain how to place the tick mark in the last column for table 1. So table 2, we have to compare the first group 0 and 1 in table 1. So now when we compare the first and second group, you can see that when we compare the minterms 0 and 1, the binary value in D differs. Here we have to take the grouping of the minterms where there is change in only one variable. So here in D there is a change in variable for 0 and 1 minterm. So those two are compared and they are written as 0, 1 and the values, common values are written as such 0, 0, 0, and the variable where there is a change is replaced with a dash. Similarly, in table 1, we again compare 0 with 8, 0 of group 0 with 8 of group 1. There we can see that the first variable or the A, variable under A alone has a change and remaining 3 are same. So that is written as 0, 8, and the first variable is replaced with a dash and the remaining values are written as such. Similarly, so now the grouping of 0 and 1 is over, and next we go for the grouping of group 1 and group 2. So I have to compare the minterm 1 with 3 and minterm 1 with 9. Similarly, 8 with 3 and 8 with 9. So the common values are to be written as such, and the variables where there is a change has to be replaced with a dash. We have to take into account the comparison of the minterms for only a single variable change. If there is a change in 2 or more variables, we should not take them for comparison. So having this rule in the mind, we form the table 2, where I compare minterm 1 and 3 and I get the value 0, 0, dash 1 in group 1, and I compare 1 and 9 in group that comes under group 1, where the value is dash 0, 0, 1, and next comparing 8 and 9 minterm, I get 1, 0, 0, dash. Now when you just see the table, when I compare 8 and 3, you can see that there is a change in the first digit, there is a change in the third digit and fourth digit. So the comparison of 8 and 3 cannot be taken for table 2. Similarly, we compare the group 2 and group 3 in table 1 and group 3 and group 4 in table 1, and we get the table 2. So now one thing which we have to have in mind is, when we take the minterms for grouping, if it is coming under comparison and if it has been brought to table 2, those minterms need to be checked, or a tick mark should be placed in the corresponding minterm. So here I have taken 0, 1, 3, 9, 8, 7, 11 and 15. Almost all the minterms in table 1 has been covered. So I am placing a tick mark for all the minterms which have been taken for comparison. Now with table 2, we have to move forward to table 3. Here again we compare the group 0 and group 1 of table 2, group 1 and group 2 of table 2, and group 2 and group 3 of table 2. So here again we have to check whether there is a change in any single digit. So only single digit changes can be taken for comparison, and if you are having 2 or more changes, that should not be included for comparison. And the same rule applies if the particular grouping has been taken, that particular group should be placed, that is we have to place a tick mark for that particular group. Now comparing group 0 and group 1, I am comparing 0, 1 minterm with 1, 3 minterm. Similarly, 0, 1 should be compared with 1, 9, and 0, 1 should be compared with 8, 9. And from group 0, 0, 8 should be compared with 1, 3, 0, 8 should be compared with 1, 9, and 0, 8 should be compared with 8, 9. So comparing these two, we create the third table. So I have compared 0, 1 and 8 and 9, and I have written dash 0, 0, dash. Because we can see that when we compare 0, 1 and 8, 9, you can see that the first digit has a change and the last digit already has a dash in common. and B and C also are taking up the C values, same values. So I have to replace 0189 as dash 00 dash. Similarly, I am comparing 08 and 19 group and I get the value as dash 00 dash. Similarly, I compare the terms in group 1 and group 2 in table 2 and group 2 and group 3 in table 2 and I derive the table 3. So now we check whether it is possible to go for further comparisons. Now, when we see the group 0, 1, 2 in table 3, we can understand that no further grouping is possible. So, we stop with this. Now, we take up the pending values for which tick mark has not been placed. Now, you should have already placed a tick mark for all the variables in table 2 as all the categories or all the groupings have been compared and have been used for creating table 3. So now only in table 3, these three terms are left without a tick mark. So we take these three terms into account. So now our expression becomes y of a comma b comma c comma d equal to, so the first term is b dash c dash, the second term is b dash d, and the third term is c d. Now this is the expression we get out of table 3. This is not the reduced expression, and now we have to go for the next step called prime implicant table, from which we reduce the given function which we have obtained in table 3. So in prime implicant table, we have to write the terms which we have obtained from table 3 in the column wise, and then we have to write the min terms which have been given in the problem in the first row. Now the first term b dash c dash, it is covering min term 0189 which we can get from the table 3. Now we can see that the first term b dash c dash is being covered by 0189. So here this 0189, so that particular values are, we place a cross mark to those values 0189 for b dash c dash. Next term is b dash d, that is covered by 13911 and I place a cross mark for the corresponding min terms in the second row. The third term cd covers 3, 7, 11, 15 and that is being covered by min terms 3, 7, 9, 11 and 15. So I place a cross mark to 3, 7, 11 and 15. Next step is we have to check which column has got single x. Now we can see that the column with min term 0 has got a single x. Next, the column with min term 7 has got a single x. The column with min term 8 has got a single x. And the column with 15 has got a single x. So I just placed a dash or underlined the terms, min terms which are having single x in that particular columns. Now I have to check or see the corresponding product term. So the corresponding product term for the cross mark placed in min term 0 is b dash c dash, which is covering 0189. So I have to place a tick mark to 0189. Similarly, the next cross, single cross, is for min term 7 and that is being covered by 3, 7, 11, 15. So I again place a tick mark to 3, 7, 11, 15 in the first row. Now we can see that almost all the min terms are covered, and if b dash, c dash and c and d are covering all the min terms, then we need not include b dash, instead we can omit b dash. Now our expression becomes y of a comma b comma c comma d equal to bc plus cd. So this is the minimized expression. Now coming to the advantages of Quine McCluskey minimization. So it is very efficient to be used in computer algorithms. It gives the simplified and minimal form of Boolean functions. It can be used to simplify any number of variables, unlike K-map where the number of variables is limited. Thank you for your patient listening. Let us meet again in yet another session of e-learning. Thank you all.